This is the case of Ebstein's anomaly. You can see this is left atrium, left ventricle. This is right atrium. This is atrialized right ventricle. The part of right ventricle that is atrialized because the tricuspid valve has shifted towards apex. You see the septal leaflet especially has shifted towards apex. Mitral valve is taking origin from here, but the septal leaflet of tricuspid valve is taking origin from here. So this is the case of Ebstein syndrome because the septal leaflet of tricuspid valve has shifted very much towards apex. So this is atrialized right ventricle, and this is true right ventricle. This is right ventricle, true right ventricle. This is right atrium, and this is atrialized right ventricle. So this is the case of Ebstein's anomaly because criteria wise, it has to tricuspid valve has to shift at least 7 mm per meter square of body surface. So this is the case of Ebstein's anomaly. Next image, you can see this is patent foramen well flow from right atrium to left atrium, that is reversal of flow. That is the responsible for the cyanosis in this case. You can see this is patent foramen well, color wise it is below, so color is indicating flow from right atrium into left atrium, so flow reversal. This is the flow through tricuspid valve. This is tricuspid valve. So sometimes you will get confused with pulmonary valve, but that is tricuspid valve. You can see the jet is very low in position compared to normal tricuspid valve. This is TR jet. Again the same TR jet. So this is tricuspid valve, very big valve. This is tricuspid valve, and this is atrialized right ventricle, and this is true right ventricle. So this is right ventricle, and this is atrialized right ventricle, and this is tricuspid valve, and this is TR jet. Same thing. This is pulmonary valve. This is pulmonary valve. You can see this is pulmonary valve. This is true right ventricle, and this is tricuspid valve. So in this case, this is tricuspid valve, this is pulmonary valve, and this position, if in case of normal relationship, this would be the position of real tricuspid valve, but in this case this is the position of tricuspid valve because of the normal displacement of tricuspid valve. You see, so this is pulmonary valve, and this is tricuspid valve. You can see this anterior leaflet of tricuspid valve here. You have to measure the position length of free verse part of the anterior tricuspid leaflet because that is utilized to repair the valve. So this is TR jet, and this is pulmonary registration jet. This is TR jet. This is pulmonary registration jet. Again this is TR jet. This is tricuspid valve. So very less amount of septal leaflet and larger length of anterior tricuspid leaflet is here the mobile portion. So you have to find out mobile portion of anterior tricuspid leaflet because that is utilized in case of repair of Ebstein's anomaly. Again the same thing. This portion is left atrium, this is left ventricle, this is right atrium, this is atrialized right ventricle, and this is true right ventricle. Again the same thing. Same thing. You can easily see this part has this septal leaflet and the anterior leaflet is not touching each other, so there is poor coaptation, ultimately leading to severe TRZ. Whenever you find this Ebstein's anomaly, usually you will see the severe TR without much raised right ventricular systolic pressure. So this case has got severe TR without high right ventricular systolic pressure. You can see the TRZ. So this is the case of Ebstein's anomaly with patent foramen oval. Patent foramen oval has right to left flow. The cause of deoxygenated, that means cyanosis in this case. So this is the case of, this is, here you can see patent foramen oval with flow right to left. This is apical 4-chamber view. This is right atrium, this is right ventricle, this is left ventricle, this is left atrium, and this is true right ventricle. So the true right ventricle is relatively smaller compared to atrialized right ventricle, and right atrium is severely dilated. You can see the length of, this is the diameter of left ventricle, and diameter right ventricle has got much more compared to left ventricle. So in this case, the right atrium, right ventricle is severely dilated. Again the apical 4-chamber view, same thing, apical 4-chamber view. This is pulmonary valve. This is pulmonary valve, this is pulmonary artery. Usually in case of Ebstein's anomaly, you will find normal sized pulmonary valve and pulmonary artery. So main pulmonary artery and pulmonary artery branches and pulmonary valve will be of normal size in most of the cases. That is the point to know. This is tricuspid valve. You can see the tricuspid valve is closer to pulmonary valve in the case of Ebstein's anomaly. Thank you.